Hey Mr. Bennett, Madeline here. For my final project, my two topics were trigonometry, more specifically SOHCAHTOA, and our distance, time, and speed word problems that we did in semester 1 with Miss Bray. SOHCAHTOA, as you may know, stands for the ratios of sine, cosine, and tangent. Sine would stand for opposite over hypotenuse. So SOH. Ca would stand for cosine, which is adjacent over hypotenuse. And tangent would stand for opposite over adjacent. These ratios are used when we need to find an angle or the side of something, like the side of a right angle triangle and a right angle triangle only. An example for this might be, say we had a right angle triangle that had 10 meters was its height, and we were trying to solve for R. And we knew this one angle. It was 20 degrees, but we were solving for R. So from this angle, we're looking for the hypotenuse, and we have its opposite. So we'll be using SO, which is sine. So to solve, sin 20 is equal to R, opposite over hypotenuse, which is 10 over R. Next, R times sin 20 is equal to 10, and then R is equal to 10 divided by sin 20. Now solving, that would come to R is equal to 29.24 meters. So now we have solved for the side that we were given, and that's how you can use SOHCAHTOA. Moving on to our distance, time, and word problems. So the formula used for this is D is equal to RT. D being distance, R being our constant rate of speed or average rate of speed, and T being time. Now in our first semester, we had more complicated problems. For example, Dawn drove to the Oasis in 2 hours, and Holly walked to the Oasis in 10 hours. How far is it to the Oasis if Dawn drove 16 miles per hour faster than Molly walked? With these questions, we had to use substitution to set them equal to each other and do a lot more math along with this formula. Today, I'm just going to be giving a simple problem. Holly drove to school in 6 minutes at a speed of 16 miles per hour. How far away is Holly's school? So we have this formula. We're wondering how far away is Holly's school. So that's what we're solving for. We have our speed, 16 miles per hour. Our time, 6 minutes. Of course, we need to change minutes to hours. So after doing some unit multipliers, you'll have your time is equal to 0.1 hours. Now, using the formula D equals RT, we'll just plug in our values. D is equal to 16 miles per hour times 0.1 hours. That will come to 1.6 miles, meaning Holly's school is 1.6 miles away from her home or wherever she started. So that's how these questions are solved and just what they are. But now, how do we use them in real life? SOHCAHTOA is used in oceanography, when calculating the height of tides in oceans. Also, calculus is made up of trigonometry and algebra. So in university or when we go into calculus, we'll need to know this information. Trigonometry is also used by engineers, medical services technicians, mathematicians, statisticians, chemists, building inspectors, and it's also used if you have to, say, calculate a height of a tree or a building. Architecture and engineering relies on triangular supports. When an engineer determines lengths of cables, height of support towers. Trigonometry helps them calculate the correct angles. Now, as for our distance time word problems, say you need to know how long it will take you to get somewhere. If you know how far away it is, and you know the speed in which you'll be driving, you can simply use the formula d equals rt, manipulate it so that you have time on its own, so which would be time is equal to distance divided by your speed. You'll know how long it will take you to get to your chosen destination. We also use formulas like this in science, in kinematics or motion. Now you might be wondering, how are these two topics connected? As you might have noticed, both topics relate to distance. So here we're solving for distance, and here we're finding a length, or it could be a distance. Now I've created a question combining the two. So as you can see here, a balloon is hovering 800 feet above a lake. The balloon is observed by the crew of a boat as they look upwards at an angle of 20 degrees, as you can see here. 25 seconds later, the crew has to look at an angle of 65 degrees, as you can see here, to see the balloon. How fast was the boat traveling? So to start off, we can create two right-angle triangles. One right-angle triangle is the one found right here. It's 800 feet, and we know this angle is 65 degrees, and we'll call this length down here x. We can also create a second right-angle triangle, which looks a bit more like this. This length is still 800 feet, but this angle becomes 20 degrees, and this length we'll call y. We're solving for x and y. So using our SOHCAHTOA ratios, to solve for x and y, we're going to need tan 65 is equal to 800 over x. So we'll times both sides by x, which would give us x tan 65 is equal to 800. And then divide both sides by tan 65, which would give us x is equal to 800 divided by tan 65, which, after some rounding, is 800 divided by 2.14. So x is roughly 373.83 feet. Now, same goes for y. So tan 20 is equal to 800 over y. So we do basically the same thing, except it's with tan 20, not tan 65. So we'll get to about y equals 800 over tan 20. And then tan 20 is roughly 0.364. So y is roughly 2,197.80 feet. So now we have our two lengths. We can, if we go to our original diagram and redraw it, we have this entire length, which is 2,197.8. But we also know this, which is 373.83. Now, in order to find this distance, we just find the difference. So 2,197.80 minus 373.83 feet. So the distance the boat traveled is equal to 1,823.97 feet. So now that we know how far the boat traveled, this is where we connect our distance, speed, and time word problems. Using this formula, d equals rt, we know our distance, d is equal to 1,823.97 feet, and we know our time from in the problem, 25 seconds. we're solving for how fast they went. So if you manipulate the formula, you will get r is equal to d over t. Plug in your values. You'll get a speed of 72.96 feet per second. But we want our speed in miles per hour. So using some unit multipliers, we want to convert it to hours. We'll get a speed of 262,656 feet per hour. But now we need to change it to miles per hour. There's 5,280 feet in a mile, so using another unit multiplier, we will get, after some rounding, that the speed is roughly 49.75 miles per hour. If we wanted to round again, it would come to 50 miles per hour, but I'll just leave it there. So after using SOHCAHTOA to find the distance, and then using our speed word problem formula, the d equals rt, we have now found the speed. So that is how you would use these two topics to, if you put them together, to solve a problem. They both have distance, so we've used the SOHCAHTOA to find the distance, and then we actually use the distance with this formula to find the speed. A lot of math topics are connected in different ways, such as this one, and we can use them together to solve different problems. That's it from me. Say hi to Goose.